One thing you may have noticed when you first started using Vray for SketchUp is the prolific use of the term subdivs in many parts of the renderer's user interface elements. Understanding what that term refers to and how our numeric subdiv values will affect the quality of our final renders is, in my opinion, an essential piece of the puzzle regarding our ability to use Vray for SketchUp in a production environment. Now, as I am going to be talking about the rendering process, I just want to open up the options editor for ourselves so we have access to Vray's control parameters. Whenever we start a render in Vray, we are really initializing the ray tracing process. During this, our render engine collects information from our 3D scene by means of rays that are cast and then traced through that environment. Our image sampler, sometimes called anti-aliasing controls, are the ones that actually determine the number of primary or eye rays that will be used during this process. However, depending upon the setup of our scene, of course, secondary rays may also need to be traced. Secondary rays are required to produce many of the blurry or noisy effects that ray trace renderers such as Vray are so good at producing. Effects such as blurry reflections, blurry refractions, depth of field, motion blur, area or soft edge shadows, ambient occlusion, and, well, quite a bit more. The number of secondary rays used to calculate these effects, for the most part, will be controlled by our subdiv values. This is why a subdiv setting is present in so many Vray tools. Something that is worth noting here is that the values we set in our subdiv fields don't actually describe the number of samples being used to create a particular effect. Rather, they represent the square of them. So a subdiv value of 8, which oftentimes is the default in many Vray tools, could more accurately be described as 8 multiplied by 8. That would of course give us a total of 64 samples or rays that could be used to create a particular effect in our scene, such as blurry reflections. Now, we use the word could very deliberately here, because there are actually another set of controls in Vray that will determine just how many of those potential 64 rays or samples are actually used in the final render. These controls are found in the DMC sampler rollout. When creating blurry render effects, internally, the Vray renderer is making extensive use of a class of randomized computational algorithms that are known as deterministic Monte Carlo, or DMC algorithms. This, of course, is a term that we've already encountered in our use of Vray. So whenever it is that we see any of these noisy effects being rendered in a scene, well, DMC algorithms are being heavily utilized by Vray in that process. The brilliant thing about our DMC sampler controls is that they allow us to tune just how finely our DMC algorithms work in these instances. For this reason then, many Vray users ask just what parameters should be used inside of the DMC sampler rollout. Well, of course, every scene will have unique aspects that can and will affect pretty much every setting we use in Vray, including our DMC sampler controls. So really, the best we can do is to give you some general usage guidelines. Hopefully, these will serve as a foundation from which you can fine-tune each of your scenes. Generally speaking, for the most part, we can leave everything inside of the DMC sampler rollout set at its default. Of course, if we have a need to set a minimum number of subdivisions higher than the default setting, then we can most definitely do that. But as we say, generally speaking, we can leave everything at its default in here and just work with this noise threshold value. This really can be used to switch between what I think of as draft and final render settings inside of our DMC sampler. If we are working on test or preview renders, then threshold values of between 0.1 and 0.01 are generally pretty good. These values mean that we will very rarely, if ever, make full use of the settings used in our image sampling and subdiv controls. What we will get, however, are very fast renders. When it does come time to create our final rendered output, well, values of between 0.008 and 0.002 tend to work very well. In fact, my default starting point is a value of 0.005. From that, I then fine-tune my scene. These settings will allow V-Ray to make full use of the values that have been set in our image sampling and subdiv parameters. Of course, as with any increase in quality, we're bound to experience slowdown in our renders, but the images we get back will be extremely clean with regard to the blurry effects or noisy effects that are contained within them. Now, it has to be said that this brief overview of the subdiv and DMC sampler controls may be a little dry, a little bit technical for some, but we have to reiterate that the DMC sampler plays a critical role in the V-Ray rendering process. All too often, it is tweaked just a little as an afterthought or maybe even ignored by many users. Hopefully though, this brief overview of these controls will help you avoid making just such a mistake.